So imagine trying to learn how to drive a car, right? But you're only allowed to use a computer mouse.
Oh, man.
Yeah, you just sit at a desk, you watch this high-definition video of a steering wheel turning, and, you click your left mouse button to simulate pressing the gas pedal, you drag the cursor across the screen to, check your rear view mirrors.
Right,
But
right.
you never actually grip a leather wheel. You never feel the physical resistance of the brake pedal pushing back against your foot. And you definitely never sense that subtle rumbling vibration of the engine when you accelerate into traffic.
Yeah, that's a terrifying thought. You really wouldn't want to share the highway with a driver who learned to navigate a multi-ton vehicle entirely by, clicking a mouse in a controlled air-conditioned room.
No, definitely not.
The cognitive understanding of driving might be there, sure,
Yeah.
but the physical reality of managing the machine, it's completely absent.
And yet, that is precisely the reality for a massive amount of industrial training happening right now. I mean, people are learning highly complex, potentially dangerous physical procedures entirely through flat screens.
Yep.
So whether you manage a team, work out in an industrial field yourself, or, you're just insanely curious about how humans learn complex physical skills, we are exploring a real paradigm shift today. Welcome to the deep dive.
Glad to be here.
We are looking at a system called Field IQ 2.0, which was developed by EON AI Ventures. And it takes this remarkably pragmatic approach to solving this exact vulnerability. I mean, they're fusing basic, everyday physical objects with advanced AI to basically unblock a major bottleneck in augmented reality training.
And, that vulnerability you mentioned, it really cannot be overstated. We are talking about heavy industrial enterprises here, energy sectors, massive manufacturing plants, global process industries.
Right, high stakes.
Exactly. These are environments where a single misstep doesn't just mean a failed test score. A mistake can shut down an entire facility, or worse, cause a catastrophic safety incident.
Wow.
Take a gas skid, for example. A gas skid isn't just some generic piece of machinery.
Right.
It is a massive, highly pressurized system of pipes, valves, compressors, all designed to regulate volatile materials.
Yeah.
Turning the wrong physical valve on a gas skid or even turning it in the wrong sequence, that can lead to an explosion.
Jeez.
So for years, these industries have struggled with this critical training gap, between digital theory on a screen and the unforgiving physical reality of the factory floor.
Right, and the tech industry's typical answer to this gap has always been to promise some, futuristic hardware solution. I think Dan Legiscar, the founder and chairman of EON AI Ventures, he diagnosed this perfectly.
He really did.
He basically said the entire industry has been paralyzed, waiting for perfect augmented reality glasses to arrive before they reinvent training. Everyone is waiting for this mythical, lightweight pair of smart glasses that feel just like your standard Ray-Bans but project these flawless, interactive holograms over massive industrial equipment.
Yeah, and that waiting game is a common and honestly incredibly costly trap in enterprise technology.
Oh, for sure.
Companies delay necessary improvements today because they're anticipating this perfect technological utopia tomorrow. But EON AI Ventures bypassed that trap by just refusing to wait.
Right.
Field IQ 2.0 doesn't rely on some future generation of hardware. It relies on the devices workers are already carrying in their pockets.
The phones.
Exactly.
Yeah.
Everyday smartphones, standard tablets, and the first generation of display glasses that are already widely available right now.
Okay, let's unpack this because this brings us to the core innovation, and it is just beautifully low-tech at its foundation. It's called the Field IQ board. It's essentially a printed image of industrial equipment. An organization can print a picture of a single valve assembly, or they can produce a massive full-scale wall print of an entire complex gas skid.
Right.
And then they mount that printed image on a magnetic surface. It's almost like high-tech industrial fridge magnets meeting a 3D hologram.
Yeah, that's a great way to put it.
Right, because when a trainee points their everyday phone or tablet camera at this flat printed picture, the software recognizes the image, and a live, interactive 3D model just rises off the wall on their screen.
And what's fascinating here is, well, the visual augmented reality is impressive, obviously, but the critical breakthrough is the physical interaction.
Yeah.
The trainee isn't just tapping the glass of their iPad to interact with the 3D model. They are holding real physical tools.
Wait, really? Real tools?
Yes. They use actual lockout devices that snap magnetically right onto the exact components shown on the printed board.
Oh, wow. Let's expand on that, actually, because the lockout device is the perfect example of why this matters so much. For those who aren't familiar with industrial protocols, A lockout device, it's often part of a procedure called lockout tagoot, or LO2.
Right, highly critical.
Yeah, it's literally a physical padlock and a plastic hasp that you clamp onto a machine's power switch or valve. It basically ensures that no one can accidentally turn the power or the gas back on while a technician is inside the machine fixing it.
Exactly.
I mean, it is a fundamental life or death procedure.
It really is.
Yeah.
And the psychology and physiology of learning that procedure are entirely different when you introduce physical touch.
Right.
Like watching a beautifully rendered three-dimensional wrench turn on an iPad screen. That's a cognitive exercise.
Sure.
It engages your visual cortex, your analytical brain. You understand the sequence of events. But physically gripping a lockout tool, feeling its weight in your hand, aligning it with a specific spot on a board, and snapping it into place. That engages your central nervous system. You are building true muscle memory.
Yeah, it fundamentally changes how the brain encodes the information. It's proprioception, right?
Yes, absolutely.
The body's ability to sense its own movement and location in space, it just kicks in. You're feeling the physical resistance required to do the job.
Precisely. You encode the spatial awareness required for the task. You are learning a lockout procedure, the same way you learn to drive a car, or ride a bicycle, or swing a golf club.
By doing it.
Right. You learn not by watching a simulation, but by physically executing the motion until the sequence becomes second nature.
Okay, I'm tracking with you on the muscle memory benefits. But let's be real for a second. Snapping a plastic tool onto a flat fridge magnet is not exactly a one-to-one physical replica of crawling around a multi-million-dollar three-dimensional gas skid, right?
No, of course not.
I mean, a printed wall cannot simulate the claustrophobia of working in a tight space or the complex angles of a real pipe assembly. Does interacting with a flat board actually translate to the real world?
That's a fair point. A flat board is certainly not a perfect substitute for the real asset. However, the objective here isn't to create a flawless physical replica.
Okay.
The goal is to build that crucial baseline of muscle memory and procedural confidence at a fraction of the traditional training cost. And the value really becomes clear when you analyze the sheer logistical nightmare of traditional industrial training.
Right, which changes the math entirely when you factor in the geography of these heavy industries. Because if you have a crew of 15 people who need to learn how to operate a highly specialized piece of equipment, that equipment is rarely just sitting in a convenient downtown office.
Exactly.
It is often located at a remote facility, maybe an offshore rig or some distant processing plant.
And the logistics of that traditional model are just staggering. You have to fly those 15 trainees to the remote location. You have to house them, feed them. And the most exorbitant hidden costs. You have to take that multi-million-dollar physical asset offline.
Oh, wow.
You are actively halting production and losing revenue just so trainees can practice turning valves and applying lockout devices.
Okay, so with the magnetic board system, a company can just swap out large-scale scenario maps on the wall in seconds.
Yes.
They are effectively turning any standard classroom, a temporary construction site office, or even like the inside of a marine vessel into a fully functioning hands-on training bay.
Right. They eliminate the travel costs entirely and remove the need for operational downtime. The trainees get the critical physical repetition, they memorize the spatial layout of the control panels, and they internalize the safety sequences locally.
That makes so much sense.
Yeah. So by the time they actually set foot near the real, dangerous, and expensive asset, they have already physically executed the procedure dozens of times.
So it isolates the exact physical procedure they need to learn, stripping away all the friction. And, you know, if you zoom out and look at how a worker actually progresses from a rookie to an expert out on the floor, this magnetic board is really just the middle step of a much larger, cohesive methodology. From the source material, the entire system is built on a very clear three-rung training ladder structured around a show me, let me try, evaluate me philosophy.
It is a classic pedagogical structure, but here it's applied across 3 distinct technological modalities to match the trainee's progression. The first rung of that ladder is Field IQ Anywhere.
Okay.
This represents the full virtual training phase. A trainee can access a massive digital archive, we call it the Genesis Simulation Library, and they can make any piece of industrial equipment appear instantly in their living room or a hotel room using just their phone or tablet camera.
So this is the show me phase. It provides absolute accessibility. An employee can familiarize themselves with the visual layout of a machine from anywhere on Earth with zero logistical overhead.
Exactly.
And then they move to the second rung, the Field IQ board. This is the tangible augmented reality phase we've been discussing, where the digital model meets the physical tools on a printed magnetic surface. This is the let me try phase, where cognitive learning translates into physical muscle memory.
And following that physical repetition, we reach the final stage, Field IQ Live. This is the physical AR phase. The trainee is finally deployed to the field, standing directly in front of the real operating machinery.
The real deal.
The real deal. They receive step-by-step guidance overlaid directly onto the physical asset. But the critical shift here is the hardware. They might review the procedure on their phone initially, but they ultimately put the phone in their pocket.
Oh, interesting.
Yeah, they switch to smart glasses that recognize their location and serve them visual cues at the exact right moment, entirely hands-free.
Here's where it gets really interesting, though, because that progression makes perfect sense, from entirely virtual to safely tangible to live and hands-free. But looking at that sequence, a major hardware question sort of pops up.
Okay.
If smart glasses are the ultimate goal for hands-free work on the actual factory floor, why bother starting with phones and tablets in the first two stages? Like, if the industry wants glasses, why not train on glasses from day one?
If we connect this to the bigger picture, it really reveals a deeply strategic understanding of resource allocation and, frankly, the physical realities of industrial environments.
How so?
Well, smart glasses are incredibly useful for hands-free live execution. You know, when a technician's hands are covered in grease, they're holding heavy tools and they need to reference a schematic overlaid on a physical pipe.
Right.
But smart glasses are still relatively expensive, they have limited battery life, they can be fragile, and they are definitely not universally distributed. Not every single employee in a 10,000-person global workforce has a pair sitting on their desk.
Right, but everyone has a smartphone in their pocket.
Exactly. By utilizing a tiered training ladder, the organization matches the hardware to the specific need of the learning phase. You use the smartphone in the anywhere phase because the goal is infinite reach. You want thousands of employees to access the library instantly without the massive capital expenditure of buying thousands of headsets. You use the phone combined with the magnetic board because you need a cheap, scalable way to build safe, repetitive muscle memory. Only when the trainee has proven they understand the sequence and they're standing on the real asset in the live phase do you deploy the highly specialized, expensive, hands-free capability of the glasses.
Got it. It's like crawling, walking, and then running while ensuring you are only paying for the running shoes when the person is actually ready to sprint.
Perfect analogy.
So we have spent a lot of time exploring how this physical-digital bridge helps the individual trainee learn faster and safer. But the broader implications for the organization itself are equally profound. The technology eventually shifts from being a pure educational tool to becoming an enterprise intelligence asset. The real power behind the scenes isn't just the magnets or the 3D models. It's the underlying artificial intelligence.
Yes, the AI functions as this invisible, over-the-shoulder instructor. While the trainee is physically snapping those lockout devices onto the magnetic board, the AI is actively tracking every single placement.
Wait, tracking it how?
It isn't just recording a video. The device's camera uses spatial computing to map the geometry of the physical board. It recognizes the shape and location of the physical tool, compares it in real time to the ideal sequence mapped on the 3D digital twin, and then it immediately scores the trainee's actions.
Oh, wow.
Yeah, it knows instantly if a physical step was skipped or performed out of order.
So what does this all mean? Mats Johansson, the president of EON AI Ventures, he refers to this capability as work intelligence made physical. It's a concept that fundamentally redefines the value of a training exercise. Every verified physical action a trainee performs, whether manipulating a digital twin in their living room, snapping a physical tool onto the magnetic board in a site office, or executing the final procedure on the live asset with smart glasses, it's all captured.
Right.
It is scored, verified, and compounded into the organization's overall knowledge base.
And if you consider the position of a manager running a massive industrial facility under the traditional model, it's wild. You send a crew to a week-long training seminar, they watch instructional videos, they pass a multiple-choice written test, and then they return to the floor. As a manager, you are largely operating on hope.
Just hoping for the best.
Right. You hope they internalize the safety protocols. You hope they actually possess the physical coordination to turn the high-pressure valve safely. But under this new model, hope is replaced by verified, digitized data.
Yeah.
The organization have empirical proof that the technician possesses the exact physical muscle memory required to execute the sequence flawlessly.
Which sparks a much larger conversation about how corporations treat institutional knowledge in the first place. Historically, training is viewed as a necessary evil, right?
Oh, absolutely.
A one-time event and a massive cost center. You invest heavily to train an employee, and then that critical operational knowledge just lives entirely inside their individual head. When that master technician retires after 30 years or leaves for a competitor, their deeply ingrained expertise basically walks out the door with them.
And this raises an important question, right? EON AI Ventures, and they're drawing on a 25-year history of deploying immersive learning across more than 80 countries. They're proposing a structural solution to that exact problem. They describe a three-part mechanism they call the intelligence flywheel.
The flywheel, where?
It begins with Genesis, which is the platform for authoring the 3D simulations. Then it moves to Field IQ, the system for guiding the actual physical field work. And finally, it closes the loop with Assess IQ, the AI mechanism for capturing and scoring that verified competency.
They are essentially turning human physical skill into a permanent corporate asset. It is a staggering evolution. I mean, the heavy industry sector went from being paralyzed, waiting around for magic holographic glasses to solve their problems, to slapping industrial magnets on a printed wall, and finally to building a compounding AI brain that permanently records exactly how to maintain a global power grid.
It really is a highly effective synthesis of available technology. They identified the core psychological requirement of learning physical muscle memory, and they reverse engineered a solution using the absolute most accessible tools at their disposal.
Right. And, for anyone navigating complex problems, whether you're in heavy manufacturing, software development, or even a corporate boardroom, there is a really profound lesson here about the nature of innovation. It is a masterclass in not waiting for the perfect technology to arrive from the future.
Yeah, exactly.
True innovation is often about looking at the mundane tools we have right now, smartphones in our pockets, simple magnets, printed images, current AI tracking, and just combining them creatively to solve immediate, deeply physical problems.
And as we consider that compounding AI knowledge base, it actually leaves us with a rather profound philosophical challenge.
Oh.
Well, the overarching goal, as described by the architects of this system, is to build a permanent, verified record of how expert work is done. But if every single physical action of a master technician, every subtle sequence, every specific tool placement, every nuanced adjustment is captured, verified, and permanently encoded into an AI-guided simulation, what happens to the unique value of human intuition on the factory floor?
That is a fascinating question.
Right. Once the absolute perfect way to execute a physical job is permanently recorded and instantly downloadable to any worker anywhere in the world, does human expertise simply become a commodity that a company can just install?
Wow. If an organization can essentially download 20 years of spatial awareness and muscle memory directly into a new hire's headset, the definition of what it means to be an expert will have to completely change.
It really will.
We will leave you to chew on that one. Because as we've explored today, you cannot learn to drive a car just by clicking a mouse, but we are rapidly approaching a reality where the car itself can physically guide your hands on the wheel. Thank you for joining us for this deep dive. Keep asking questions, keep looking for the physical connections in an increasingly digital world, and we will catch you next time. Keep exploring.